These are the steps in the process of the scientific method. In the scientific method, we observe some sort of event or other item going on in the world around us. Once we've made that observation, we form a hypothesis or an explanation of what that observation is and why it occurs. A hypothesis is sometimes misunderstood as being a guess, when really it's an educated idea of why that is happening. Once we have a hypothesis, we make a prediction based on that hypothesis. The prediction is what allows us to create an experiment or a test to gather additional observations to determine if the results support or refute our hypothesis. We keep going through this process until we have a good idea of what is going on and why. If we have results that are consistent with our prediction over and over, this will add to our knowledge and allow us to eventually create theories or laws based on our observations or our hypothesis. If our testing does not support the hypothesis, we can always go back to the beginning. One thing that's often missing from understandings of the scientific method is this iterative process. It's something that continually builds on itself. We want to be continually revising things. This scientific method or way of thinking is incredibly important in a variety of fields and can be even important in your day-to-day lives. For example, let's say that you observe that you have a stuffed up nose. Your hypothesis might be that maybe you're having allergies. Based on that prediction or on that hypothesis, you might make the prediction that if it is allergies, I shouldn't have a fever. To test that prediction, you could then perform an experiment or a test. And tests and experiments don't have to be super complicated. Some of them are very simple, very quick. In this case, I could just take my temperature. If I find that my temperature is elevated, then I might think, oh, maybe it's not allergies, maybe I'm sick, maybe I have something else. If my temperature is normal, that would support my hypothesis that it's allergies. Now, I would want to do a variety of tests to really be sure, is this allergies or is it something else? So I might look at a bunch of different alternative hypotheses. So I'd look and see what else it might be. Here's another example of the scientific method in action. In this case, Bob gets sick after eating bread. Bob makes the hypothesis that he's gluten intolerant. Performs an experiment. He tries each of the following a time in between: crackers, bread, gluten-free crackers, and gluten-free bread. But all of them end up making him sick. So the conclusion that we can make is that Bob is not gluten intolerant. This experiment does not support his hypothesis. So he would need to go back through and determine what is actually making him sick. There may be a bunch of different alternative explanations. Perhaps he's actually allergic to wheat or something else that's in the bread or in the crackers. Throughout this process, it's important to always keep in mind alternative explanations for what is going on and think about, are you actually testing for what you want to test for? In the previous example with Bob, if he had simply cut out bread, he wouldn't have realized that it had nothing to do with the gluten, that it was something else entirely. So it's very important to think about, what are you actually testing for? What does the information actually tell us? I do suggest that you take some time to come up with some observations of things around you. Try and determine, can you form a hypothesis, make a prediction, and what experiments could you do to actually test those predictions to make additional observations. This is a very useful process for a wide variety of applications.